All right, so today is the first lesson, the second part of the comprehensive math class. This is the last for one more semester, okay? And we are going to talk about sequences today, okay? There are two types of sequences. One is called the arithmetic sequence, other one geometric sequence. Now, why we call it geometric sequence? Because there is a reason here, because it's coming from geometry, okay? All right, so a sequence, okay, we have a sequence of numbers, okay, A1, A2, A3, and right? So that this is the nth term. This is called a geometric sequence, okay? If the ratio of the consecutive terms is the same, so that means A2 over A1 is going to A3 over A2, and A4 over A3, and keep it going, they're equal to R. They're all equal to R, okay? So it's the same constant if the second term over the previous term, okay? So that means, okay, that means A2 can be written as A1 times R. A3 can be written as A2 times R, but A2 is already A1 times R, so it's A1 R, right? That's A2, right? So then you can return as A1 squared, okay? And similarly, A4 is going to be A3R. So what is A3? A3 is A1R squared and times R. So when you multiply this out, it's A1R cubed. So now you probably can figure out the pattern. The pattern is the nth term is the first term times R to the, I think it's just one less, so it's n minus 1. So this is the general term. Okay, so that's called a geometric series. Okay, a geometric sequence. And some examples. Examples, right? Examples, for example, yeah, you have a sequence of 3 and 6 and 12 and 24, right? And 48. This is a geometric sequence. Okay. The reason is the ratio. It's always double, double, double. Right? The first term is 3. Okay. So how can we find the general term, right? A1 equals 3, right? The ratio is going 3 over 6 over 3, 12 over 6, 24 over 12, 48 over 24. So they're all equal to 2. Okay. They're all equal to 2. So the nth term, the general term, you can get is A1 and R to the n minus 1. So it's going to be 3 times 2 to the n minus 1, right? And you can double check that. Check, you know, check is the A4 is going to 3 times 2 to the 4 minus 1. So 3 times 8, and which is 24. Right, so then you can even figure out the hundredth term. The hundredth term is 3 times 2 to the 100 minus 1 is 99. Okay. All right. Now, there is a very important formula. Okay. We have the very important formula is 1 plus R squared and R to the, let's say, to the K. This is it, and together is R1 plus 1 minus R to the 1 minus R to the K plus 1 and 1 minus R. Right. The question is, can we prove it? Can we prove it? Here's a proof. Okay? We shouldn't know the proof, not only just memorize it. The proof is you let S to be 1 plus R squared R to the K. Okay? So we want to get a simple expression on the right hand side, right? So what I'm going to do is I multiply S by R. So you multiply each term by R. But when you multiply them out, it's going to be R plus R squared, R cubed, and here's R to the K plus 1. All right, now what happens? That's equation 1, that's equation 2. Equation 1 minus equation 2 is S minus RS. And then this is a common part, right? So that would be gone 1 minus RT, K plus 1. Yeah. The left-hand side is 1 minus RSS. Okay, so S is going to be 1 minus RT K plus 1 over 1 minus R. Right, so here's a couple examples. So it's 1 plus 2 plus 2 squared and 2 to the 2019, right? If we add them together, right? So according to the formula, it is going to be 1 minus 2 to the 2020, right? So, but I can switch it out, the denominator is -1, so it's going to be 2 to the 2020 minus 1. So many terms, 2000 terms added together, just equal to 2 to the 2020 minus 1. But this is a little bit surprise, right? So this number is getting huge. Okay, this number can. There was a story about there was a king. Someone asking king give him what is kind of reward he can get, right? And he said, give me one piece of bean, for example, right? The first day, second day just double it. The third day is double it. Okay, and for 10 years maybe. The king think, oh, that's easy. Well, just 1, and then double is 2, 2 double is 4, right? But if for the entire year, and that'd be huge. That's maybe the whole country, that cannot afford it. Okay, so this is a number, is huge number. Right. Now, how about R is a small number, 1 over 2, 1 over 2 square, 1 over 2 to the 100, or in 2019. Right. According to the above formula, and that is going to be 1 over 1 minus 1, yeah. This is 1/2 to the 2020. So I'm going to have to simplify. The denominator is 1/2. Right. So it's be 2, 1 minus 1/2 to the 2020. Right, so that's what we get. And clearly this number is always smaller than 2, right? Because when the second part is, it's minus. So it's smaller than 2 minus 0, which is 2. So many terms adding together, no matter how big of the number, right? Right now, 2020, this is always smaller than 2. Right? Let me repeat again. So many numbers adding together is less than 2, less than 2. Okay? So if you want to increase the number from 2019 to 1 billion, I think you still get the number, get a sum less than 2, but getting close to 2. Okay? So so this is a number smaller than 2. Okay. So that number is very small, can be ignored. Okay. So let's take a look at even more general, okay? And you have a 1 plus 1 over 2, 1 over 2 square, 1 over 2 to the any large number. Let's call it k, okay? K could be 1 billion, 1 trillion. Okay, according to the above formula, that is going to be 1 minus 1 half, 1 minus 1 half to the k plus 1. Right, so what do, after we simplify the denominator, which is just equal to 1 half, and the same idea, it's going to be 1 minus 1 half to the k plus 1. But this number is always smaller than 2, right? No matter what happens, because it's 1 minus something. Is it getting close to 2? The answer is yes, okay? 1 over 2 to the k plus 1. Getting close to 0 as k approaches infinity. It's getting huge number. 1 trillion, 1 billion. Okay? Because this number can be simply written like a 2 to the k plus 1, right? So the denominator is getting larger, larger. The numerator is getting smaller, smaller. So what does that mean? That means if I let k to be sufficient large, left hand side almost equal to right side. The right hand side is just 2 because this goes to 0. This, right? So what I conclude, we can formally write in the following the sum of infinite many terms, right? Infinite many terms. Okay, this is going to be 2. Okay, so this is identity. They're equal because it's the sum of infinite many terms. Okay, but any finite sum will be smaller than 2. Yeah, clear. So that's about geometric series and geometric sequences. Okay. All right, now let's look at a geometry problem. Okay, here's a question. The idea is very simple. We have a let's see. Yeah, we have a just take a look at the simple problem. Okay, square. Okay, this is a unit of square 1 by 1. Okay. And I divided them into equal 4 parts. Okay, then I divide them into 4 equal parts. Then I divide them into 4 equal parts. Okay. And the idea how to, yeah. Then what we're going to do is, I'm going to mark this area. Okay, then this area. Then this area, then this area, then this area. So you have infinitely many squares going, okay? Shrink the point. So what is, how do you define the total area? What is the area of shaded region? Right? All right, so let me show you how to do it, okay? I just call this one area 1, the first right? Area 1, area 2, area 3, area 4. So the total area is going to be A1 plus A2, A3, right? Add them together. So next question, you get infinite many sums, right? So many terms. Okay, how do you add them together? So let's calculate the area for each of them. Okay, so A1, the side length, let's say little A1, A2, right? A3. So AK is going to be AK squared, the edge length, right? So the A1 is already equal to 1/2. A2 is 1/2 and 1/2, A1 over 2, right? So it's going to be it's going to be 1/4. Okay, and keep it going. This is going to be A2 over 2. Okay, what is A2? 1/2 squared, so now we have 1/2 cubed. So what do we get? We get the general formula, little ak is 1 over 2 to the power k. And now I'm going to put it into here. Okay, what I'm going to do is ak squared is 1 over 2 to the k and the square. But this can be exchanged. K times 2 is 2k. All right, so the sum A is going to be A1, 2, right, and A2, because this can be written as 1/2 square and to the power k. Okay, so that's going to be 1/4 of k. So I should write a quarter instead of 1/2 square. All right, so now how do you add them together? You have so many terms. And the total area should be less than 1, right? Right, so how do you do? Well, you can, then there's leading term is not the 1. That's you can add the 1, doesn't matter, right? Or subtracting, right? So I is going to be 1/4. So be careful. This is not start from 1, right? So how do I do? Just assume there's 1 here. So it's going to be 1 over, right? 1 over 1 minus r, okay? But that you have to subtract 1 because, then let's recall that. It's 1 plus r squared, r cubed. This is going to be 1 over 1 minus r if the absolute r is less than 1. Okay, and why we get this? Let's go back. Yeah, take a look at this example. Now when k sufficient large, this term goes to 0, right? So it's just 1 over r, okay? Let me repeat this again. So first of all, you have only r to the power k, right? So that is 1 minus this over 1 minus r. But you let go both sides, k goes to infinity. And this side, k goes to infinity. So if the absolute r is less than 1, this approaches 0. Okay, so you will get one minus 0, right? It's 1 minus r. Okay, so we have this formula. We use this formula to solve the above problem. So we have a equals 1/4 square, and 1/4 cube. And that's going to be 1 over 1 minus quarter minus 1. right? Because when is missing, you just assume there's 1 here, then you have to subtract them, right? All right, so the answer here is that is going to be 4 over 3, right? Minus 1, that's going to be 3 over 4. That's going to be 1/4. Okay. So it's about 1/3 of the region. When the area of this sequence of squares have an area of 1/3. Right. But then if you look at just 1 square, this is the area of 1/4, right? This is 1/4 of the area, total area. All right, so this is about geometric sequence, okay? Remember, we needed this in the future, okay? All right, the sequence sometimes can be defined in the way by some formulas. For example, AN is defined by n equals n minus 1 minus n minus 2. So here n is greater than or equals 3. Okay, if A1 is 1, A2 equals 2. What is A1 plus A2 all the way to A100? Okay. So any idea who can try this? And how to add them together? But you have to try and find a general formula, right? That's a key point. Can we find a general formula? But the formula is not given directly. An equals the difference of 2 previous terms. Okay, I give you 1 minute to think about, okay? Maybe you can figure out a pattern and maybe find all the sums. Those are usually 2-step problems. You probably have to find the general formula for AN. Okay. All right, can we figure out a pattern? All right, so let's start, right? So A1 equals 1, A2 equals 2, okay, fine. Right. Then A3, right? A3 equals A2 minus A1, so it's 2 minus 1 is 1. Right, it's repeated, right? A4. A4 is going to be A3 minus A2. So 1 minus 2 is -1. Oh, that's different, right? So 1, 2, 1, -1. A5 is the difference of this 2 be -2. A4 minus A3, -1 minus 1, -2. Okay, A6, -2 minus -1 will be negative 1. Okay, well, that's so far does not look like good, right? So you see, 1, 2, 1, -1, -2, -1. Okay, let's try 7. A7 is going to be A6 minus A5, which is 1. Okay, A8 is the difference of those two terms, which is going to be 2. So I think this is a cut line. So after that, you repeat the same, you get a 1, 2. It begins 1, 2, right? 1, 2. Then you find the second, third term. So it's a periodic sequence, surprise. Once it's a periodic sequence, we can find the sum. Okay? Why? Because A1 plus A2, A to the 100, you can group them. You have A1, A2, A3, A4, A5, A6. That's one block. Okay? And then A7, A8. Come on, right? So it's A12. And then so on. The problem is there's the last term, right? Yeah, the last term. All right, so the last, 100 divided by 6. The remainder is the remainder is 4. There are 4 terms left. Okay? So that means the last term is just partial. There should be 4 terms. Okay, this is the partial block. All right, so in order to add all together, you just needed to figure out the sum of the 6 terms because it's periodic, right? The sum of these 6 terms, let's add it together. So A1 plus A2, A3, A4, A5, A6 is going to be 1 plus 2 plus 1 minus 1 minus 1 minus 2 minus 1. I'm surprised it's going to be 0. Okay? So the sum of the 6 numbers in each block, it's going to be 0. All you needed to know is get 0 plus 0 plus 0, right? How many zeros? 16 zeros. The last term is A7. A7, I'm going to A7 is, let's start again. 1, 2, right? 1, 2, 1, -1. Okay? It's going to be 1, 2, plus 1, plus -1. So the answer is 3. Okay. Yeah, the answer is 3. So we find the general formula. Right? We find the general formula. Okay. So it's this is type of sequence is defined by formula. Okay. And defined by formula. Now let's take a look at another. Take a look at this one. Okay. N is defined by N equals 2 times N minus 1 plus X. Okay. And can we find the general formula? If possible. Right. And the first term, we don't know. The first term, we don't need to know which is N greater than 2, right? Yeah. And A1, let's call it A, okay? Find the general formula without N. minus 1, okay, without the previous terms. Express it in terms of A and X. We have to find the formula, right? Okay, how do you do that? You still have to figure out a pattern to get and make then guess, right? What kind of power it should be, right? So AN equals, let's say A2 equals 2 times A1 plus X. It's 2A plus X. Okay, fine. Okay. Then let's take a look at A3. Twice of A2 plus X. Okay, so you replace it. A2 replaced by it, right? It's 2A plus X. Now be careful, you don't add them together. So you will write a 2 squared times A, and then 2X, right, plus X. And the continual A4 is 2 times A3 plus X. So A3 is this. Okay. Now you know why I don't add them together. You got 2X plus X is equal to 3X. No, I'm not going to do that. Right? So what they get is 2 cube A, and 2 times 2 is 2 square. 2 times X is plus 2X and plus X. And now I have a pretty good idea. So this is like a sequence here, 1 plus 2 squared. So if you have AN, then 2 to the n minus 1A, right? Plus 2 to the n, the difference is 2. All right? Now what? Well, I think I don't need to worry about that. How about those terms? We have a common factor here, right? You take an x out. So inside parentheses is a geometric series, right? It's geometric series. So add them together, use the formula we have. It's going to be, remember, 1 minus 2 to the n minus 2 plus 1 is the n minus 1. And the denominator is just negative 1. So I'm going to change the order. It's 2 to the n minus 1 times x. Right, so this is general formula. All right, let's see. Well, remember, we have a couple of formulas for the sum. You know, this is a plus 2, plus 3, plus 4, all the way to n. And this is n plus 1 divided by 2. Okay. Another formula is a plus, it's 1 plus 2 squared plus 3 squared plus 4 squared n squared. And that is going to be n times n plus 1, 2n plus 1 divided by 6. Okay. The third one, sometimes we use it, is going to be 1 plus 3 cube, 2 cube, 3 cube, 4 cube, n cube. And that's going to be half of n plus 1 square. Okay, so let's check the first one. Okay, 1. So it's always perfect square, right? 1 plus 2 cube is going to be 9. 9 is going to be 3 square. Right, we can check that. So 2 cube plus 3 cube is going to be it's 9 plus 27, 36, 36, 6 square. So it's always perfect square. Okay, 6 square is going to be just 1, 6 is just 1 plus 2 plus 3 square. And here is going to be 1 plus 2 square. All right, so now let's take a look at following problem. Right. AN is going to be 1 plus 2 plus 3 all the way to n. Okay. We want to find out a to the 2020 minus a to the 2019. Okay, what is that? All right, can you do that? Nobody gave me answers. Quickly, quickly, come on. Yeah, I'm waiting for your answer, okay? So the 2020 is 10 minus 2019 is 10. Joshua, are you there? Yeah, that's right. That's easy trivial problem, actually. Okay, you know what? You don't add them together, okay? A 2020 is going to be 1 plus 2 plus 3 all the way to 2019 plus 2020. A 2019 is 1 plus 2 plus 3 all the way to 2019. So the difference is just 2 terms canceled out. Right? So that's why 2020 minus is going to 2020. Done. Right? Now, if I ask you to find 75, 8 to the 50, how can you do that? Is there any idea? In this case, you have to find the sum, okay? AN is going to be NN plus 1 divided by 2. Okay. So A75 minus A50 is twice of 75 times 75 plus 1, 76, minus 50 and the 51 over 2. Okay, any idea? Yeah. So how do you simplify things like that? You have to multiply this out, right? But that's a tricky here. Okay, that's tricky here is you don't need a small trick, right? 50 and 75, that's the ratio, right? So 75, okay, 75 is 3 times 15, right? So you have a common factor, you should take it out. Okay, so common factor is 2 here. So it's going to be 3 times 15 times 76. And here's 2 times 15. No, sorry, not 3 times 25. 25 times 51. So you have a 25 taken out. Then you have 3 times 76 minus 2 times 51 over 2. So 2 canceled out. And this will be, right? This is well, this is 76, right? 76 divided by 2, 38. And multiply by 3. Okay, then minus 51. Okay, then you calculate this. Right, this is actually is going to be 38 times 3 minus 51. Okay, then times 25. Okay, it's going to be 1575. All right. So let's look at another geometrical problem. What is uh, what is the fifth term in the geometry sequence? Okay, if the first term is 625 and the eighth term is going to be 1 over 125. All right, how do you solve this problem? First of all, it's a geometry sequence, right? So you know that the geometry sequence can be written in the form a times r, a square, a r cube, right? ai cube, and ar to the fourth term, right? And then general term is a to the r to the k. We're given the following information. We're given the following information, right? A is going to be 625. And a to the r7, a times r7 is 125. Okay. So first of all, you figured out what is I think this is 5 to the fourth power, okay? And this is going to be 25 times 25 times 5, so 5 cubed. Okay. So r to the 7th, this term divided by that term, right? It's going to be a to the r7th divided by a. So it's going to be, right? So it's going to be 5 to 7, 1 over 5 to 7. And then it's easy to see, oh, that's I is going to be 1 over 5, right? Then you can figure out what is the fifth term. Fifth term is r to the fourth power. A is going to be 5 to the fourth power, and I is going to be, right? That's going to be what? Okay. So you can get a general term because after determining R and A, you can get all the terms, right? So the general term is going to be a times r to the n minus 1's power, right? So this is a 5 to the 4th power. And here's a 1 over, I is 1 over 5 to the n minus 1 power. So you combine them, you will get, okay, you get subtraction here. I think I can express it in the denominator. So it's going to be n minus 1, n minus 5, actually, yeah. Okay, you can express in this form, or you can express in this form. Doesn't matter. All right, then I'm going to talk about arithmetic sequence. Arithmetic sequence, other sequence, so the difference of two consecutive terms will be same. So if A1, A2, A3, right? So the difference is going to be always the same. Okay, it's going to be always R. And then you can get a general term, okay, if you know the first term, because if A1 is A, right, then A2 is A plus R, right? A3 is going to be A plus, right? But A2 plus R, so it's going to be 2R, increased by R each term. So the general term is going to be A plus n minus 1 times R. So that is the general formula for the arithmetic sequence. Okay, arithmetic sequence. Now let's do some problems. Arithmetic sequence. Yeah, let's take a look at all the problems. Yeah, there was a problem on the Mathcounts. Okay, so we know that x plus 2, x plus 4, x plus 6, and x plus 2n. Okay, so consider this sequence. It is an arithmetic sequence because it's increased by 2. How many terms here? You have n plus 1 terms. Okay, here where x is an integer. Okay, what do we know that? We know that is x cubed. Okay, each term is cubed. We know that add them together is going to be negative 1,197. Okay. So what is the value of n? If n is greater than 3, okay. We must have a 3 terms. So this is it's really the challenging problem because you cannot find the formula directly. So to solve this type of problems, you have to recall the formula cube, right? Okay, the formula for the cube as the sum of this cube numbers, okay, is at least I'm getting, yeah, first of all, the only formula we know is 1 plus 2, 1 cube plus 2 cube plus 3 cube, right? N cube is going to be n times n plus 1, 2n plus, that's a square, okay? So cube is n plus 1 square n square. All right, now if you use this formula to find the n, it's possible, but takes much longer time, okay? It takes much longer time. This is then another formula where maybe we need is this formula. Okay, why with that? You can add them together. You can get an equation, okay? In x, the left-hand side involve x, and the right-hand side is constant, okay? You can find it, okay? You multiply this out, and actually you can, you can find an expression on the left-hand side, but it's very complicated. You involve x, involve n. So this is not the way we can do, okay? So there must be a trick here, right? So the idea is that you have to make a simple observation. If this formula is too complicated, yeah, you can get, you can, because x plus 2 squared, you can expand it, okay? No problem. So back to the more elementary methods, okay? You look at that. You look at this, right? 1 cube plus 3 cube is 28. And I tried to get to 1,197. 153. And 1 cube plus 3 cube plus, because all those are even, they're different by the even, they're different by even number. So if x is odd, then all the numbers are odd. If x is even, all the numbers are even. Okay. And so that's why you have to use the 1 cube, 3 cube, and the 5 cube, 7 cube. I get 496. Okay. Then continue, because I want to get the 1,197. So I get 1,225. It's bigger than this, right? This is bigger than 1,197. Then you stack it. So how do you do that? And you look at the difference, how much increase part. Then sometimes you come back, wait for a while, and come back, look at this problem. I'm never able to get to 1,197. But when you look at the difference, okay, 1,225 is going to be 1,197 plus 28. So what does that mean? Okay, what does that mean? That means, because this part is 28, right? That means the 5 cube plus 7 cube plus 9 cube is going to be what I want. Okay, but then you say I solved the problem, right? I have a sum of those three other numbers cubed is going to be 1,197. But it says that we should have how many terms? We should have more than 4 terms, more than 3 terms. I cannot have 3 terms. N is greater than 3. So N is greater than 3 means I need to have at least more than 4 terms, right? Yeah. But I have, but I do have this one, right? But that's okay. And you can make it negative, right? Negative 9 cubed plus negative 7 cubed plus negative 5 cubed plus negative 3 cubed plus negative 1 cubed plus 1 cubed plus 3 cubed is still going to be, right? Because that cancels out. It's 2. And now you have how many terms? You increase it by 2 each time. 1, 2, 3, 4, 5, 6, 7. Okay, so that's why x is going to be 9, negative 9. Negative 9 plus 2, negative 9 plus 4, negative 9 plus 6, negative 9 plus 8, right? So negative 9 plus 10, negative 9 plus 12, okay? So actually, x should be equal to negative 9, n is going to be 6. Okay, that's how do we get. Yeah, since this should be the best way to solve the problem, because like if you have a time, you may be able to solve the equation by guessing, trying to solve the equation, just expand it. Yeah, so so you add them together, okay? You add them together, then you can get an expression in terms of x and n. Okay, here's my idea. Okay, so x cubed plus x plus 2 cubed, and then x plus 2n cubed. I just give a sketch. You get all the terms, and then you factor it. You will get something like that. Okay, 2n squared, 2nx, and n cubed. Wow, this is very complicated. Okay, so. And we know that's going to be negative 1,097, but the negative 1,197 is going to be negative 3 squared, 7 times 19. Then you compare, okay? Then you compare, you find out n plus 1 should be 3, n plus x should be 7, plus minus 7. So eventually you can figure it out, n should be equal to 6. And the x should be equal to negative 9. So that works, okay? Yeah, and then you have a 9. Okay. So n x is n plus x, so negative 3, and negative 9 plus 1 is negative 8. Yeah, negative 7. Yeah, 7. Okay, so from here you can guess in trying to figure out the numbers. So those are about sequences. There are lots of problems about sequences. Sometimes, those two types of sequences mixed up. Like one sequence is geometry, other sequence is a semantic sequence. Sometimes the sequence you get does not belong to any of them. You have to find out the secondary sequence. And from the secondary sequence, you get the general solution. Okay, so I just do one more problem, then we'll finish. Okay, for example, given 1, 7, 25, 61, 121. Okay, what is the next term? This is a very typical problem. What is the next term? Okay, what is the next term? The way you do is you take a difference, right? and then you take a difference, and the nth term will be, right? So A2 minus A1, 7 minus 1 is going to be 6, right? Usually, you try to see what you can, right? Is it a arithmetic sequence? Maybe not, okay? So A3 minus A2, 25 minus 7, I think it's going to be 18, right? Then A4 minus A3. So the original sequence, there's no pattern, but if we generate a new sequence by take a difference, and then you will find out, yeah, and A is at 25, it's going to 36. And then there's a pattern here, right? And the 121 minus 61, right? So it's 60. So what do you get here? You will get 6 times 1, 6 times 3, 6 times 6, 6 times 10. And then can you see the pattern or not? Right? Okay. How do you get the 1, 3, 6, 10? Okay. So if we can figure out this pattern, then 1, 3, 6, 10. Then you figure out the next term. Okay. And I just want to tell you that it's this second term is going to be, 1 is 1, right? 3 is 1 plus 2 equals 3. 6 is 1 plus 2 plus 3 equals 6. 1 plus 2 plus 3 plus 4 equals 10. So this is how do we get it, right? Right? 1 is going to be 1. So 1, 3, 6, 10 is going to be sum of those terms. So this is another trick here. Then you get, you will see that the next term here should be 6 times 10 plus 5, right? It's going to be 15. So A6 minus A5 is going to be there. So then A6 is going to be A5. A5 is going to be 121 plus 6 times 15. Okay, that's how do we get? Okay, then you get to the next term. Get the next term. Okay, so I'm not going to complete this computation, and you got the lesson. So the idea is that take a difference and try to figure out the pattern for the sequence you generate. And sometimes, yeah, you need to, yeah, it's not easy, like 1, 3, 6, 10. This actually turns out to be the sum of the first n terms. Okay, this is important observation, and then you solve the problem. All right, okay, now we stop here.